Hello, and welcome to Getting Started with AWS IoT Core for LoRaWAN, Multicast Downlink. My name is Greg Breen, and I'm an IoT Specialist Solutions Architect with AWS. This video dives straight into the Multicast Downlink feature of the AWS IoT Core for LoRaWAN service. To follow along, it's helpful if you're already somewhat familiar with LoRaWAN, LoRaWAN classes, Multicast, Unicast, and the AWS IoT Core for LoRaWAN service. To use the Multicast Downlink feature, you must have a LoRaWAN device that supports the LoRa Alliance Application Layer Clock Synchronization specification and the Remote Multicast Setup specification. You can find links to these specifications in the video description. Most LoRaWAN devices do not support the Remote Multicast Setup specification at this time, so please check your device documentation. In this video, I'll demonstrate Multicast Downlink using an ST-Nucleo WL55JC evaluation board. The STM-Cube WL firmware includes the LoRaMac node reference stack. This stack includes implementations of the specifications mentioned on the previous slide. I'll now demonstrate Multicast Downlink, specifically Multicast Downlink to a group of Class A devices that temporarily switch to Class C. The steps we'll take are, firstly, create a wireless device with assigned F ports for the application layer clock synchronization package and the remote multicast setup package. Secondly, create a multicast group. This synchronizes the device time and sets up the multicast keys. And finally, schedule a downlink message to assign the multicast start time, duration, frequency, and data rate, and also to assign the payload and the F port on which to send the downlink message. We begin by creating a new wireless device. We configure the wireless device specification, the EUIs and the keys, and the device name in the normal way. We then enable FUOTA because it's currently the only way to assign the clock sync and multicast F ports in the console. For LoRaWAN 1.0.x devices, we need to supply the Gen app key. This is the root key for deriving multicast session keys. Please check your device documentation. For this ST-Nucleo device, it's just the app key again. We also need to assign the F ports for the multicast, FUOTA, and clock sync packages. The default values are usually correct, as they are for this ST-Nucleo device, but please consult your device documentation. Select your profiles and your destination as you normally would, and then create the device. Now we create a multicast group that the downlink message will target. We select the RF region the device is in and select Class C as the type of multicast. Normally, a multicast device would include multiple devices. For this demonstration, however, just a single device is in the group. At this point, we introduce the ST-Nucleo's serial terminal. Here we can see that the device has joined the network and is sending uplinks once per minute. We create the multicast group and drill into the group's details. The group status is pending because no session start time has yet been scheduled. The individual device status is package attempting because the multicast group has not been initialized on the device. Upon the next uplink, AWS IoT Core for LoRaWAN issues commands from the application clock layer synchronization specification to synchronize the time, and commands from the remote multicast setup specification to create the multicast group. With the multicast group created on the device, we can observe that the status of that individual device has changed to multicast setup ready. Note that the multicast group session is not yet scheduled, and therefore no start time, session duration, RX frequency, nor RX data rate has yet been assigned. We can now schedule a downlink message. The session start time has to be at least 30 minutes into the future because AWS IoT Core for LoRaWAN needs to send setup messages to every device in the multicast group. We can select any preferred frequency and data rate for the downlink message. The ST Nucleo accepts LED on and off commands on FPort 2. Here we schedule a base 64 encoded command that will turn the LED on. The group now has a session start time. Its state has changed to session waiting and the device state has changed to session attempting. Upon the next uplink, AWS IoT Core for LoRaWAN issues a command from the Remote Multicast Setup specification to schedule the multicast Class C session. The device is now furnished with the session start time, session duration, RX frequency, and RX data rate. Accordingly, the individual device state has changed to session ready. At the scheduled time, the device switches to Class C. The downlink message is received and the LED turns on. At the expiry of the session timeout, the multicast session concludes with the device switching back to Class A. With the session finished, we can refresh the console and see that the group status has returned to pending. Thank you for watching this video. If you have any questions, please ask them at repost.aws, where you can leverage the entire AWS community. I may see you there. Goodbye for now.